This is an example of a double replacement reaction. There's a couple different ways you can do these, but this is the way I do them, and this is the way that I showed you in class, so this is the way I'm going to do it. You leave the first element of each compound at the beginning where it was before. So I'm going to go ahead and put the Al in here. Now, as far as the 2 goes, you can only bring those subscripts if it's part of a polyatomic ion. That 2 is not a part of a polyatomic ion, so I can't bring it. Okay, I don't know whether you can hear my cat or not, but hopefully not. Okay, so then you take the negative parts of which is the back part, the last part of each compound, and you switch them. So the nitrate has to come over with the aluminum. And I brought the 3 with it because it's a part of nitrate. So since nitrate is NO3 -1, I have to bring the 3 with it or it's not nitrate anymore. And then for the sulfate, you have to decide, are the 4 and the 3 part of sulfate? Well, the 4 is and the 3 is not. So we bring the 4 but not the 3. And then you check the chart to see if it works. One of these 2 has to be a precipitate. Remember, a precipitate is a solid. So one of them needs to be solid, or if you're looking at the back chart, it would say not soluble. So if either one or both say solid or not soluble, then the reaction works. And I believe if you check that chart, it'd be this second compound, silver sulfate, up here that's not soluble. If it does work, then you have to balance out the charges. So you go back, and aluminum has a +3, nitrate has a -1. So we have to put the nitrate in parentheses and use 3 of those to cancel out the aluminum. And then silver has a +1, sulfate has a -2. So we're going to have to use 2 silvers to cancel out the sulfate. Then you have to go back and erase all charges, because you can't have charges in your final answer, and balance your equation. Looks like I need 2 aluminums. Makes 6 nitrates, which makes 3 silvers. 3 times 2, I guess, is 6 silvers and 3 sulfates. I think that's balanced. And then that equation is done. So there's our answer. I hope this helps with double replacement reactions.